U value of window glazing and glazing components. How does it work, the calculation, the numerical calculation of the U value for these components?
Yes, there are numerical calculations for the assessment of the energy performance of transparent building components or windows. The calculation is a standardized method. So as the window is an inhomogeneous building component consisting of different parts and materials, we first calculate the heat transfer coefficient of the single part. So the U value for the glazing, the UG, we calculate according to a standard, or it is provided by the glazing manufacturer. Then we calculate the U value of the frame, the UF, with a finite element software under standardized conditions. And another important thing to consider is the thermal bridge at the glazing edge, so the connection between glazing and frame. To do so, to calculate these three main values, we only need a drawing of the window profile and information about all the materials used. After that, we calculate the overall U window value, weighting all the heat transfer coefficients of the single parts according to their dimensions.
So, if I understood correctly, the strategy is to break the window on the components that make the window. So we have the frame, the glazing, and then there is the thermal bridge, which is this area between the frame and the glazing, correct?
Exactly.
Okay.
The psi value. And when do we need this kind of calculations? As I said, we only need a drawing of the window profile. So it isn't quite easy and thus cheap and fast way to calculate and to assess the energy performance of transparent components and windows. So it can be a fast alternative to testing or dynamic testing in the lab. It can thus support the development process of a window. So because you can just easily compare different solutions, you can change the shape of the profile or add and change different materials. So it's a fast and quite easy way to develop to support the development of the window prototype. On the other hand, these calculations are important for the CE marking of the final product. So it's important for the calculation of the energy performance of the final product in general, and in particular for the CE marking.
So at European level, to meet our standards in Europe?
Yes, there are several methods to come to these values. So the UF value can, if it's not a complex facade system, it can be assessed with a simplified method using tables that you find in another European standard. Or you calculate them, as I said, with finite element software. And this calculation of the UF in this case and the psi has to be done by a accredited test body to be used for the CE marking then.
So this means that in Europe, if for instance I design a new window system, it's not enough that I do the calculation myself as manufacturer. I need to go to someone that is allowed to actually say this is the right value.
Yeah, so it is like that. The window manufacturer can calculate himself the overall U-window value, but if he uses calculated values for the frame and for the thermal bridge and for the glazing, that calculated values have to come from an accredited body.
Okay.
The sense of accreditation is that we follow a standardized method, though this method can be easily applied to in the same way to various window types in this case. It is important to have accreditation because it's a kind of quality assurance. The accredited test institution has to ensure that the engineers that do the calculations are trained in a special way, and they follow a standardized workflow. And the test body is also controlled and tested regularly by Accredia. They are responsible for the accreditation of test bodies in Italy. Yeah, and on the other hand, accredited calculations are necessary and mandatory, as I said, for the CE marking of the final product.
So for a window manufacturer, this is really important. But I was wondering, so I see the point to do this for new products, but I also know you have a lot of experience in existing buildings and retrofitting the facade. So how do you work with these standards when you meet a historic building and a historic window?
Yeah, that's true. We are working a lot with little window manufacturers that restore historic wooden windows mainly. And here we use this kind of calculation to assess the energy performance of the existing historic window. And then we assess different solutions with different level of invasiveness. So in order to also avoid the exchange of the window. So for example, if we have a box type window with 2 layers of sashes, then we test the solution of, for example, only exchanging the inner glazing from a single pane to a vacuum glazing. So, yeah.
And all this with numerical calculations?
Yes.
So I guess all these numerical methods that we saw together today are usually enough and sufficient with the majority of technologies we see in the market. But we should refer to experimental testing for the more complex facade solutions. They are a bit out of the standard procedure, as we saw with Stefano in the lab, correct?
Yeah, indeed.
So if we have shadings integrated or advanced materials,
yeah.
Then we need the test.
Great. I think now, Miriam, we can go to calculate the value of our facade.
I think so. Thank you.
Thank you.